Hi, welcome to CDA 5220. I will briefly cover into memory encryption. So, previously we have learned how a message, a long message may be encrypted using various encryption modes. But let's think about what if we apply the encryption to the memory. Okay? So, the first thing we want to know is what are really different between encrypting memory versus encrypting a message. It turns out there are a couple of key differences. Number one is with regard to the encryption granularity. So if you want to encrypt a long message, the encryption granularity is not such a big deal because you will encrypt one chunk and then you use whatever encryption mode you use, let's say cipher blockchaining, and you encrypt the next chunk and the next chunk, etc. until the last chunk. Okay? Now, with regard to memory encryption, it is quite different because memory encryption is applied to memory blocks, and there is already a granularity in place. So every time you want to access the memory, it happens in a certain granularity that is not controlled, or that is not necessarily the same with the encryption granularity. Okay, so for example, between the interface between a cache, like in a processor chip, and the main memory typically operates at the granularity of cache block size. Okay, so in a typical system, it may be 64 bytes or 128 bytes. So anytime you miss on a cache and you need to get data from main memory, 64 bytes or 128 bytes will be fetched. And this granularity is likely different than the encryption granularity. So that's one thing that is different. And the second thing that is different is that message is sent and received sequentially, byte per byte, as opposed to main memory, which is accessed randomly. Okay? So main memory is accessed using address. So you supply the address and then the memory returns to you data associated with that address. This is quite different than a message. Message is addressless, so you just receive a series of bytes. Now the final thing is that because memory is associated with addresses, you can have a situation in which the same address may contain many different data items or data values depending on the time, right? So you could be writing different data values to the same address over time, and it generates many different data values. What are important to consider? Okay, what other factors are important to consider? So in this case, when you receive a message, you get the entire message, but when you are accessing the memory, it happens in response to execution of an instruction. Now, typically, the execution of the instruction is a load instruction, right? Or a store instruction. So basically, either load or store instruction requires some data that is not in a cache, so it has to be fetched from the memory into the processor, into the cache. So between these two, one thing matters more than the other. Okay, so a load is an instruction executed with the intent of reading a value from memory. A store, on the other hand, accesses the data in order to write to it. Okay, so the big difference is that a load instruction has other instructions following that want to use the value that is read by the load. Okay, so therefore the time is very critical. So if, let's say, your load takes a long time, or you perform something that adds time to it, then it becomes a critical path delay. Okay, whereas a store instruction, typically the instruction that wants to use it is located way below or far away from the store itself. Okay, so the latency is not in a critical path. So thinking about that, so if you encrypt the main memory, where, between encryption and decryption, the thing that matters more in terms of critical path delay is the decryption, because the decryption typically corresponds to needing to bring data from memory into the cache, and it may correspond to a load instruction that wants to use it. Okay. Encryption, on the other hand, is less critical because it corresponds to an event in which data is evicted from the cache and needs to be written back to memory. And finally, the most important question is, what kind of encryption mode should we use? To answer this question, we have to consider that the memory access is random, and also the access time or the encryption or decryption time may be added to the critical path. So those are two of the most important considerations for this. All right, thank you. Until next time.